In this lesson, I'm going to be adding another type of enemies, which are vertical enemies. As you can see on the screen, these enemies seem to float around the level and they move on a certain range. So the first thing we'll do is add a new class in enemy.js, and I'm just going to copy and paste that code because it's similar to what we're doing in the past. So we are giving these vertical enemies a certain velocity. When you talk about velocity in y, it means it's on the vertical axis. When it's negative, it's going upwards. When it's positive, it's going downwards. So in this case, all of these enemies begin with a velocity that's on the upwards direction. We give them a gravity of 0, which means that they'll just float on the level. If you just place them there, they're not going to fall like the other enemies or like my player entity. Now the range y property that I've given this class, that's something that I've specifically added. It's not going to be processed by Quintus 2D or any of the other Quintus modules. This is something that we'll be using just for vertical enemies. It's not part of the framework. But as you can see, you can add your own properties when you define a new entity like this. Now, I want this to have certain components as well. One of them is the 2D component, as we'll be dealing with collision, and I want these enemies to be common enemies as well. So let's take a quick look at that common enemy component that we created previously. That will be present in vertical enemies as well. Now there are some values that we want to keep track of, and I want to say what the initial values were so that I can know when the enemy has moved from a certain position long enough so that it should change direction in its movement. So I'm going to save this in a variable called initial y, which will be this.p.y. That gives me the position in y when we're creating the object, as we are in the constructor method. Now I also want to keep track of that initial velocity vy. This will be this.p.vy. And same thing for the direction. We'll use the same approach that we did with the other enemies, which is to save the absolute value of the direction. This is going to be either 1 or -1. Now we want to check for collisions, because sometimes you might place some of these enemies close to the ground and they'll collide with a certain tile. So you want it to just swap the direction of the movement as it collides with some blocks. So we'll listen to the bump event on top and on the bottom, and if that's occurring, we'll switch the direction, the velocity of the enemy. Now there's something that we need to be checking for on each step, on each game tick, which is basically, have we got far enough from the initial position so that we've surpassed this range y value, and if that is the case, we need to turn back and move the enemy the other way around. So I'm gonna add that code in here. That will be the step method for this type of enemy. And all this is just a comparison of the values of the position compared to the range, and also assuming that that this thing is moving on the direction it should be moving. And if that's the case, we'll just flip the movement and direction of our enemy. Now, as you can see, we're using now a different level file. So let me quickly go into tiled and show you what exactly we're doing there. So that's 9. Let's go to data level. So as you can see, this works the exact same way to what we've done previously, but now we have some more enemies, and all that is just setting their corresponding properties here. So for example, the blue alien, it has a sheet of blue alien, the class is ground enemy. Now what about the floating ones, these ones here? Their class is vertical enemy and their sheet is gray alien. You can easily just add more of these if you want, and then they'll show on the web browser.